Good afternoon, Year 11. Today we're going to be looking at Chapter 8.3, the applications of trig. Now, I know we've already covered trig in previous years. This is more of a rehash. We'll have probably 2 of these lessons before we start learning some new applications for trigonometry. To start with, let's look at this example here. Okay, so we've got a triangle. We've got to try and find y. We're given an angle and we're given a side. Now, with any right-angled trig problem like we have here, my recommendation is the first thing you do is you write down SOHCAHTOA. If you can remember these 9 letters in a 3x3 grid, you can solve any trig problem. Now, when you've written all of them down, what you want to do is put an equals. Obviously, if you're writing this in your book, you might want to space it out a little bit. But first thing you do is put an equal sign down there. And then what you're going to do is you're going to insert a divide or a fraction, doesn't matter which, okay? I'll do a divide, but when I do the actual math for it, I'll put a fraction. And what this gives us is the ratio, and from here we can actually expand them, because S stands for sine, okay, and that is sine theta. As I quickly just look for theta. There we go. Okay, so I'll just copy and paste this one. So sine theta equals O divided by H, or as you're about to see, O over H, like so. C stands for cosine, so cosine of theta is equal to A over H. And finally, T stands for tangent, or tan theta, equals O divided by A. Alright, and there we go. What we now have are our 3 trig ratios. Now, with any trig problem, the first thing you want to do is label this triangle. So what we've got here is y. That is our hypotenuse because it's opposite the 90-degree angle. It is our longest side. Okay, so here we have h. This is our theta in here, the known angle. If we were given 2 angles, and theoretically we could actually work this angle out here, you could label either of them, as theta. Okay, but for now we'll just call this one theta. And finally, we have to think, is this our adjacent or our opposite? Now, the adjacent and opposite are all relative to what you've made your theta. Because we've made the 63.25 our theta, if you look here, notice how it's connected, this side. So we call it the adjacent. It is next to our theta. So we have H and A. We think, which trig identity uses A and H? Well, that's our middle one, cosine. Okay, so step 2 is to now go and write our ratio. Okay, so I'm just going to copy and paste this. All right, we're ready to start our question. Okay, I'll unhighlight it. So I'll just put here, just so we know that we're working it out. So we've got cosine theta equals A over H. That's step 1 and 2 done. We've labeled the triangle, written down the ratio. Step 3 is to substitute. So I'm going to take this and substitute what I know. Instead of theta, I'm going to write 63.25 because that's our angle. The adjacent we know is 4.71 millimeters, and H is what we're trying to find. Now, this is definitely the more awkward one to rearrange, but I'm going to go through it in a bit of a slower way so you can see how I go about it. The first thing I'm going to do, we're dividing by H over here. I'm going to move that over here. The opposite of dividing by H is timesing by H. Alternatively, you could times both sides by our hypotenuse. And just to show you, I'm going to label it as Y like I should have done. My apologies, guys. So this is what we're going to end up with. Going to get Y times cosine 63.25. Okay, now from there, what we're going to do is move the cosine 63.25 to the other side. Now here you'll see there's a times. So if I highlight this, move it to the other side, the opposite of times is divide. And there we go. We end up with y is equal to 4.71 divided by cosine of 63.25. That's step 4 complete. That's what we call the rearranging. Now, putting this into the calculator, I end up with an answer of 10.46 millimeters. Don't forget your units. Let's go back and see if we can make sense of this. Now, for argument's sake, if you rearranged it correctly and got an answer of less than 4.71, you know you've made a mistake. Our answer of 10.46, as you can see here, is higher than our adjacent. So it sticks true mathematically that the hypotenuse is the longest side of the triangle, making this answer correct. Okay, so there's our answer for that one. The value of y there is 10.46 millimeters. Okay, notice the units. Next, we have to find theta. Now, this might seem more daunting, but it actually isn't. Okay, it's actually quite easy. So what we're going to do is we're going to copy and paste our trig values from here. I'll unhighlight cosine for a second. I've just realised it's the one we're going to use. But anyway, so as I said, for those who weren't sure of the 5 steps, I'm just going to write them over here. Step 1 is to label. Step 2, actually I'll left align these, probably easier. Step 1 is label. Step 2 is to write the ratio. Step 3 is to substitute. Step 4, rearrange. Step 5, solve. That is your 5-step approach to solving any right-angle trig problem. Okay, so let's look at this one and let's start labeling it. The first side I always identify as the hypotenuse. You find your right angle, and the side opposite that, that's not connected to the right angle, is your hypotenuse. So 4.2 is our hypotenuse here. We've identified a theta. The question identified that for us. And now we've got a 3.3. Now, is that the opposite or the adjacent? Well, that would be the adjacent because it's 3.3 centimeters, and it's connected to the theta right down here. Okay, adjacent, next to our theta. So, A and H, it's going to be cosine again that we end up using. So, I'll just, again, put working here so we know that this is where the working starts. So, write your ratio. That's step 2 done. Step 3 is to substitute. The adjacent we said was 3.3. The hypotenuse was 4.2. Okay, that's step 3 done. Step 4 is to rearrange. Now this is where we need to use the inverse cosine function, because to get the theta on its own, we need to move this cosine to the other side. It becomes cosine to the power of -1. Okay, inverse ratio, and then I'm going to put this in brackets. If it cooperates, it sure does. So theta equals cosine to the -1, 3.3 over 4.2. From there, that is my rearranging done. Now all I have left to do is to solve. So to get your inverse cos function, I'm going to press shift and then cos, and you'll see in kind of yellowish writing, if you've got an FX82, the inverse cosine function, 3.3 over 4.2. Now, if you're getting a math error here, you've probably just put the hypotenuse on top and the adjacent on bottom, and of course that would be a math error. Okay, your adjacent can't be larger than your hypotenuse. Now, I end up with an answer of 38.21, and the units for this are going to be degrees. There we go. There's my final answer for that one. I'm just going to quickly backtrack here so it all fits on one page. Almost. There we go. Okay, so I'll tidy this up, but there's the working for these 2 questions. Remember the 5-step process, and you cannot go wrong for any trig problem that you encounter. Anyway, thanks, grade 11.